So hello guys, Engineer Going here. Again, class, we're to discuss module, part 5 of module 4. Okay, so let me share my screen. Okay, so we continue class with 4.8 or the maturity of concrete. Okay, so yeah. So technically daw class, the strength of concrete depends on both time as well as yung temperature during the early period of gain in strength. Okay. So technically class, the compressive strength gained by concrete is thus measured on its 28 day. Ay, wala kasi ako ng chart eh. Pero supposedly class, beyond 28 day kasi consistent na yan or it goes down pa. So technically class, the compressive strength, ultimate compressive strength of concrete class is determined on its 28 day. Okay? So parang, yeah. So we have here class ito. Okay, so for you to have an idea class, but not in English, we have table 4.5 or entitled class, no? The compressive strength gain by concrete with age. Okay, so for you to have an idea class, paano yung percentage of concrete strength gain with age class, ito yun. Okay, supposedly class after 1 day of curing. Okay, so di ba, you are to cure kasi, di ba class? After 1 day of curing class, supposedly the supposed strength, depende kasi yun sa concrete mix natin, di ba, kung ano yung proportioning class. Makukuha na niya yung 16% of the strength. So after 1 day pa lang yun class, meron ka ng 16% class ng compressive strength. Okay, so after 3 days class, parang nag times 3, so we'll have 40. Okay, at 7 days of curing class, you'll have 65% na rin. Technically, ito na rin class yung ito na yung basis. Okay, ito yung basis class ng removal ng form breaks natin. Okay, kasi supposedly class by 7 days, parang yun, meet na niya yung 65%. So parang kayang-kaya na niyang buhatin yung sarili niya in a way. Okay, tapos ayun class, after 14 days of curing, 90% of the compressive strength is already attained. Tapos yun nga class, at 28 days, supposedly, mature na siya. So 100% of the compressive strength is already gained. Okay, so proper curing conditions class will help in preventing the escape of moisture that will facilitate the strength gain reaction. Okay, so again class, ito yung parang intro natin for you to have an idea of the percentage strength gain of concrete in terms of age. Okay, so ang pinaka-topic natin for this chapter class is the maturity of concrete. Okay, supposedly class, we can get, maturity of concrete is defined. So annotation natin kasi sa maturity of concrete is M. It's defined as the summation of product of time and temperature of the concrete during its curing days. Okay, so its unit is in degrees Celsius per arts. Meron tayong formula class. Okay, yan. So titignan nyo class, meron tayong sample computation. So ito na rin yung pinaka-basis natin class. Okay, so from the computation class, ang pinaka makukuha natin doon class is it should be noted class that the data, yung datum natin class in terms of yung temperature. Okay, so in terms of the temperature class, meron tayong reference point or yung datum which is yung negative degrees Celsius. Okay, so may detailed explanation naman to sa video para mas mag-gets nyo. Okay, so also class, we have a chart. Ito, in terms of the relationship between maturity and compressive strength. Okay, so kung titignan natin class, as the maturity goes higher, so the higher class the maturity or the higher the compressive strength. Okay, so the higher class yung degrees Celsius per or na degrees Celsius hour, yung maturity class, mas mataas rin yung compressive strength. Tapos meron rin tayong way class para makuha yung percentage strength ng concrete in terms of yung age niya. Okay, so parang yan nga class, diba yung pinakita ko kanina. Technically kasi ito is like, di ba siya super standard, pero parang yung basis natin, paano natin kinuha yung percentage strength at certain age, meron tayong formula class. Ito yan. So percentage of strength at maturity. So technically, ang notation natin kasi percentage F prime C. So, kasi ang F prime C class, yan yung notation natin sa strength, compressive strength of concrete. Okay? So, meron tayong formula class. Ito, wherein yung, yan, na-define naman yung A tsaka B. So, yung values ng A and B class, ito yung constants. Okay? Tapos yung MN class, ito yung maturity ng concrete at the certain percentage. Okay? Tapos ito, meron tayong values class ng coefficients A and B dun sa formula natin ng percentage of strength at maturity. Okay? So for you to further understand class, meron tayong video discussion about yun. Okay? So ito, maturity class. So panoorin natin again class. Bago tayo, to summarize ko and then we'll jump to the example. Okay? Okay, so focus muna tayo sa video class, no? For the explanation of maturity. So, balik ko lang muna dito sa atin. Okay? So, yeah. Pakinggan natin, class.
Maturity concept of concrete. The strength of concrete depends upon both the time as well as temperature during the early period of gain in strength. The maturity of concrete is defined as the summation of the product of time and temperature.
So again, class, yun yung formula
Its
natin.
units are degree Celsius hour or degree Celsius days.
So dito, class, mas magandang isa lang, no? So mag-focus na tayo, class, dun sa degree Celsius hour para hindi tayo malito. Okay? So para mas clear. Okay? So again, class, for our class, unit of maturity class is degree Celsius hour.
Let's consider a sample of concrete cured at 18 degrees Celsius for 28 days whose maturity is
So ito yung explanation class ng sample computation niya. Okay.
calculated as. In general, the hydration of concrete takes place even at the temperature of minus 11 degrees Celsius.
So again, class, ito na yung reference natin in terms of temperature, no? Yan na yung data na datum, reference point natin. So parang lagi, class, kung ano yung given temperature, kailangan nating kunin yung gap niya from negative 11 degrees Celsius. Kaya natin mina-minus, class. Okay, so parang imbis na 0 kasi reference point natin, ang reference point natin, class, is yung negative degrees Celsius. So from negative degrees Celsius, class, to our respective temperature. Yun yung temperature natin dito. Okay?
Thus it is taken as the origin in the computation of maturity. The value is taken similar 19800 degrees Celsius hour. This is an approximate value. The accurate value is calculated by dividing the time into smaller intervals and observing the temperature of each and then obtaining the summation of the product of time and temperature. Besides, the value obtained with the help of approximate value also yields a sufficiently accurate value and is widely accepted. The relationship between maturity and strength of concrete is shown. The maturity concept is very useful for estimating the strength of concrete at any other maturity as a percentage of the strength of concrete of known maturity by using the formula. The value of constants A and B are given by researcher Plowman, which is shown on the screen. With the help of these values, the strength of concrete at any maturity age can be calculated. Thank you for watching. Stay tuned. The best is yet to come.
Okay? So, yun lang, class. Technically, simple lang naman. So, we have two formulas, no? So, i-summarize natin, class, for better understanding. Okay? So, okay. So, again, class, dito na tayo sa 4.8, no? 4.8. Okay, so supposedly class is the maturity. Okay? So, first up, class, discuss natin yung concrete strength. Yeah, concrete strength gained with age. Okay, para magka-idea tayo, class. Okay. So, yeah. So, supposedly, class, no, for a certain age. So, gawin natin tong in terms of days. Okay. Certain age class, meron tayong, ito, yung percentage ng compressive strength natin. Okay. So, okay na yan. Okay. So, namely class, meron tayo ng 1 day, tapos 3, tapos 7, 14, then 28. 21. Yan. Okay. So, ano yung percentage natin class? So, for 1 day class, supposedly natin na natin yung 16% ng compressive strength. For 3 days class, natin na natin yung 40%. Tapos 7 days class, natin na natin yung 65%. Okay? After 14 days class, yan, medyo 90 na tayo. Tapos yun nga, 28 days, super mature na siya. So, we can say, class, safe to say, nakuha na niya yung 100%. Okay? So, yan yung parang gist natin, class, in terms of yung strength gain at maturity. Okay? Tapos, this time, class, we talk about maturity na. So, again, class, meron tayong formula for maturity. Okay? Ang notation natin, class, for maturity is M. Okay? Yan. So, ang formula natin, class, for maturity is, so, M equal to yung summation lang yan, class, ng time. Time times yung temperature. Okay. Tapos ang unit natin dito, class, is in, again, class, for hour, class, degrees Celsius, hour. Ay, huwag tayo mag-day, class, para consistent tayo. Okay. Tapos, ang origin natin, class, in terms of temperature. Okay. So, yung, yeah. For yung temperature dito, class. No? So, for temperature, okay. Ang reference natin dito, class, di ba, is negative degrees Celsius ang ating datum or origin. Okay. Yan. Papakita ko, class, mamaya kung ano yung meaning nun. So, parang in terms of temperature natin, class, lagi tayong magbe-base from negative 11 degrees Celsius. So, whatever yung temperature natin dito, class, kailangan natin i-minus ito para makuha yung gap. Okay? With respect to negative degrees Celsius. Okay? Tapos, meron pa tayong isa, class. Pagkukunin naman natin percentage of strength. Strength at maturity. Okay? Tapos, yan. So, yan yung notation natin, class. Ang notation natin ng percentage of strength at maturity at certain maturity class, no? So, pwedeng 1 day, 2 day, 3 day, till 28. Okay, supposedly, class, ito yung ating notation. Okay, tapos ang formula natin, class, for the percentage of strength at certain maturity, equal siya, class, sa A plus yung B logarithm base 10. So, technically, logarithm base 10, yun lang yung log dun sa sa ating calculate. Tapos yung M over 1,000. Okay. So, dito, class, para may no? So, at a certain maturity, so ikaw kasi magdidictate. So, lagyan natin ng N doon. Lagyan rin natin ng N dito. Okay. So, para ang meaning lang ng N dito, class, is kung at what age ng maturity mo kukunin, syempre magre-reflect dun. So, yun yung percentage of strength niya at kung ano yung maturity yun. So, 7 days, 1 day, 3 days. Okay? So with this class, pwede na tayong sagutan yung problem. Okay. So, yeah, banatan na natin agad class para matapos. Okay. So, problem, may example. 4.1. Okay. So, ano ba yung mga given? So, kung titignan natin class, a strength of a fully matured concrete sample is found to be ito. So, find the strength of identical concrete at 7 days when cured at an average temperature of 20 sa umaga, tapos 10 sa gabi. So, parang given daw class yung fully matured concrete strength niya, parang kukunin natin class kung ano yung strength niya at 7 days. Okay, so parang kaya mo kasi siyang parang interpolate in a way using yung formulas natin kanina. Okay? So again, class, given muna tayo. So meron daw tayo class 3 at 28 days, no? Is equal to 500 kilograms per centimeter squared. Okay? Tapos class, ano daw yung kukunin natin? So, meron pa tayong ibang given class. So, meron tayong temperature. So, meron tayong temperature at paano ba sasabihin? Temperature at day. So, sabihin na lang natin AM. Equal yan plus sa 20 degrees Celsius. Okay. Meron tayong temperature at night. So, sabihin na natin PM. Okay. So, 10 degrees Celsius. Okay. Tapos ano yung required nating class? So, ang required nating class is to get yung ito. So, ano daw class yung strength natin at 7 days. Okay? Yan. So, paano ba yung game plan natin, class? So, ang galawan natin dito, class, unahin natin to. So, paano ba natin makukuha, class, yung strength at 7 days? Okay? So, may formula tayo dito. So, kung titignan yung formula natin, class, wala dyan. Dalawa lang yung formula natin, class, ito. Tsaka yung kanina, ito. So, wala dun. Kasi supposedly, class, by inspection, so para makuha natin yung class, gagamitin natin yung fully matured na. So, ito kasi yung class, di ba? This. Kasi, di ba, using this table. So, supposedly, class, yung fully matured strength niya, yun yung 100%. So, kung gusto mo makuha, class, yung strength niya at 7 days, multiply mo lang, class, kung ano yung strength niya at 28 days by yung percentage niya. But ito, class, again, ito is parang data lang yan. Supposedly, kailangan natin kunin, class. So, parang i-multiply lang natin, class, yung percentage strength niya at 7 days. Okay? Ito, kailangan natin i-solve, class. Ito, class, ito kasi is parang assumptions lang to, class, no? Hindi siya yung exact. So, wag natin gagamitin to, class. Kailangan natin i-solve. Kasi, di ba, meron naman tayong formula class sa percentage no strength at ito. Kumbaga, yung mas puwasin natin sagot dito, class, is yung percentage ng strength at certain maturity. So, yun. Okay? So, kung titignan mo, class, kung i-inspect mo yung ating formula, so ito yung pinaka-required. Ito, class, given naman na yun, di ba yun yun? So, kailangan natin makuha to. Okay? So, paano natin kukunin yan, class? Kailangan natin kukunin yung percentage ng strength at 70. So, gamitin natin yung formula na to. Ito. Okay? So, titignan nyo, class, di ba? A plus B logarithmic with base 10 no mn. So, supposedly, class, para makuha natin yung 7 days, dapat ang gagamitin natin maturity yung sa 7 days. Okay? All over class 1,000. Okay? Again, class, ang sagot natin dito is in terms of percentage na to. Kumbaga na, yeah. Okay? So, kung ano yung sagot na makuha natin dito, class, naka-percentage na siya. Kasi, di ba, percentage strength naman yung kinukuha natin dito. Okay? So, kung inspect ulit natin dito class, eto meron na tayo niyan, meron na tayo nun. Okay, so ang kulang lang natin dito class, dapat ma-solve natin yung maturity at 7 days. So, parang ito yung game plan natin class, no? So, 7 days class. So, babalikan natin yung isa pang formula natin. Ito yung formula natin class, di ba? So, supposedly class, equal yan sa, yun, summation class nung time times yung temperature natin. Okay? So, kung i-expand natin yung class, itong M at 7 days natin class, no? So, maturity natin 7 days. So, equal yan class, no? So, kung titignan mo kasi yung problem natin class, nahati siya sa dalawa. Kumbaga, iba daw kasi class yung temperature niya at night tsaka at day. So, AM, PM. Okay? So, yeah. Kaya siya parang summation. So, kailangan natin kunin class kung ano yung time niya multiplied by yung temperature. Okay? So, technically, parang ginagawa natin dito class, syempre, kukunin natin yung time times yung temperature dun sa AM or yung day natin. Okay? Plus class yung time times yung temperature natin class during the night. So, yung PM. Gets ba? Okay? So, yan na. So, kung titignan nyo pas again, no, ang galawan natin is, kunin muna natin to. Pag nakuha na natin yan, class, makukuha na natin to. Pag nakuha na natin yan, class, makukuha na natin. Kasi pag nakuha na natin yan, class, masasagot natin yan. Nakuha natin to, masasagot natin yan. So, para ang game plan natin, class, mag-start talaga tayo dun sa maturity at 7 days. Okay? So, ito nga, class, yung formula natin. Okay? So, direct sub na tayo dito, class. Kasi meron naman na tayo class nung time tsaka day. Okay? So, supposedly, class equal yan. So, ano ba yung time natin class at the day or like the AM? So, di ba, kung titignan nyo class 24, yeah, 7 days pala muna class. So, yung time natin class, di ba, at 7 days. So, dapat yung 7 days natin class. Okay? Times plus yung AM. So, dapat 7 days in the morning lang tayo. So, ano ba yung morning? Yung hati-hati plus pa half. So, parang in one day, meron tayong 12 hours. Okay? 12 hours. Diba? Okay? Yan pa lang yung time niya. Tapos, i-multiply pa ulit natin yung class, diba? So, i-multiply pa natin to sa temperature niya during the morning. So, given naman yung class, diba? Temperature during the morning class is 23 degrees Celsius. Okay? Tapos again, class, ang kukunin kasi natin class is yung temperature from an origin of yung kanina nga class, di ba? Ang origin natin class is 11 degrees Celsius. Okay? So supposedly class, para makuha natin yung gap between yung dalawa, ima-minus natin. Okay? So ito na class yung first part. Ito yung time times temperature in the morning. Okay? Supposedly ganyan yun. Okay, so since 7 days yung kinukuha natin class, tapos ang pinag-uusapan muna natin class is yung morning. So meron tayong 12 hours in the morning. Okay? Tapos i-add natin class yung sa gabi naman. So same class in 7 days yung pinag-uusapan natin. So like maturity at 7 days yung natin makuha. Times class kung ilang hours for at sa gabi. Okay, so consider 12 hours in yung class. 12 hours during a span of 1 day. Okay? Tapos yung temperature natin, class, so at night daw class is 10 degrees Celsius. Okay? Again, class, ang origin natin is ito. So para makuha natin yung gap nila, class, kailangan natin yung minus. Okay? With this class, nakukuha na natin yung maturity at 7 days equal to, So pag kinalculate natin yung class, makukuha natin yung 4,368. Again, class, kung titignan mo, no? Pag nag-con tayo, class, unit analysis, hindi, yung maiwan yun. So, yan, degrees Celsius, hour. Okay? Kaya rin natin parang iba class kasi sa klase natin, kaya natin ipilit class na makuha yung hour, degrees Celsius. So, parang, in a way, yeah, convert natin. Imbes na gawin lang natin 0.5 day, 12 hours na tayo. Okay, so dito class is equal to degrees Celsius hour. Okay? Yan. So, titingnan nyo class, nakuha na natin to. So, pag nakuha na natin yung class, pwede na natin kunin to. Okay? So, i-erase ko lang class, no? So, ang galawan natin class, nakuha na natin yan. Dito naman na tayo sa next step. So, burahin ko lang to class, no? Yan. Okay? Alisin ko na rin class yung part na to kasi nakuha naman na natin yan. Yan. Okay? So, titignan nyo class, ready na tayo dito para dito. Okay, so direct sub naman na tayo. Dito lang class para makuha natin yung values. So, meron na tayo, mag-gusto na tayo, di ba? Yan na yun. Para makuha lang natin class yung values ng A and B, kailangan lang natin tignan kung ano yung strike ng 28. So, titignan nyo class ang strike ng 28 is 500. So, nagfo-fall siya class dito, ay hindi dyan. Second to the last class, andito. Okay? So, ang gagamitin dapat natin class ng values ng A and B, ito. Okay? So, direct sum na tayo dito. Plus A. So, ang A natin, again, class is 32. Plus yung B. So, ang B natin class is 54. Okay. Logarithmic with the base 10 class of equal to. So, di ba meron tayo 7 class? So, gamitin natin yung 4, 3, 6, 8 over class yung 1,000. Okay? So, kung titignan nyo class, baka hanapin nyo saan yung logarithmic with base 10. Yun lang, yung logarithmic lang dito sa calc yun class. Okay? So, ang gagawin natin class 32 plus yung 54. Again class, hanapin mo lang ito. Yan na yun. Huwag mo nang problemahin class yung base 10 kasi matik ito, base 10 na yan. Okay? Tapos yung 4, 3, 6, 8 over 1,000. Okay? So, yan na class, makukuha na natin yung yan. So, with this class, makukuha natin yung degrees of privacy at 7 days equal to, so again class, automatic yung sagot natin, naka-percentage na to. So, 58%. Okay? So, with that class, pwede na natin makuha yung final answer. So, burahin ko lang to class, no? Yan. So, ituloy natin to sa baba. So, ito na yung pinaka gusto nating makuha talaga class, di ba? So, with this class, no? Again, yeah. So, makukuha na natin class yung strength niya at 7 days. Okay? So, ito yung formula natin class. So, kunin lang natin yung strength at 28 days. So, meron tayo ng 500 class, di ba? Okay? Kilogram per centimeter squared. Okay? Times class yung ito. So, supposedly class ito naka-percentage. So, i-multiply natin class 66.58%. Okay? So, kailangan lang natin alisin yung percentage doon class, no? Kailangan natin alisin yung percentage doon. So, i-divide natin class ng 100%. Okay? So, yan na class. Ang sagot na natin dito class, kung titignan nyo, sige, i-calculate na rin natin. 500 class times 0.6658 is equal to, yan. So, meron tayong 332.9. So, ang unit natin class kilogram per centimeter squared. So, ito na class yung strength ng concrete at 7 days. Ayan. Okay? Ito na yung ating final answer, class. Okay? So, i-compare nyo, class. Yan. Yan. So, tama yung sagot natin. Okay? So, ganun lang kadali, class. Again, wag nyo lang kakalimutan, class, no? Yung datum natin, yung origin natin in terms of temperature, dapat negative 11 degrees. As explained from the video, tsaka dun sa module natin. Okay? So, tuloy-tuloy lang tayo, class. So, moving on. Yan. Meron tayong tinatawag, class, na design mix. Mix design. So, pinaka-formal definition natin, class, ng mix design is the process of selecting suitable ingredients of concrete and determining the relative quantities with the objective of producing an economically as possible concrete of certain minimum properties. Okay, so ano yung properties in class? Workability, strength, and durability. Bale, in simple words, class, ang consideration natin in the design mix is yun, yung cost tsaka yung minimum required properties natin. Okay? So, supposedly, class, meron tayong principles in proportioning. So, to achieve, class, these objectives, so at our objectives, class, yun nga yung production of durable materials, with considering yun nga yung cost tsaka minimum properties. Ano tayong following considerations? Okay? So, number one consideration, class, the mix must be workable. Okay? Tapos, number two, since cement is the costliest ingredient in the mix, in terms of concrete, cement yung pinakamahal, the proportion should always be small as is consistent with the attainment of desired properties within wide limits. Class experiments have shown. So, ito yung nakuha natin, class, no? The strength and degree. Para ito yung mga basis natin, class, kung kailan natin babawasan yung cement. Kasi na, to attain yung parang pinaka-economical, we have to adjust the volume of cement. Okay, so the strength and degree of water tightness of mixes having like constituent materials density and workability increase with cement content. Okay, so supposedly yun nga. Strength and degree of water tightness. Yeah. Okay. Sayang ko na lang, class, no? So with the cement content, materials, and workability all constant, yun nga. Strength and degree of water tightness increase with the density of mix. Okay. So for usual methods of placement, class, the strength and degree of water tightness of well-prepped concrete and mortar are greatest when the mix is in plastic. So ang definition natin, class, ng plastic state ng mix is kapag meron siyang slump, approximately 50 mm. In terms of yung slump, kasi discuss natin mamaya dun sa testing ng concrete. Okay? So letter D, class, concrete with 4 to 7% by volume entrained air is more resistant to freezing than towing action. Okay? Through proportion concrete mix maximum resistance to fire, a porous non-combustible aggregate of high specific heat together with cement sufficient to provide the requisite strength should be thoroughly mixed. Okay, so yeah. Proportioning concrete of mature which is to be subject to freezing. Minimum amount of water in a quick setting cement should be used. Okay. Lastly, class, no? So concrete for load construction should be made from a carefully graded hard tough aggregate bound together with a small proportion of rich mortar. Okay? So simplihan lang natin to, class. Read na lang. Okay. So technically, class, we talked about yung mix design 4.9. Specifically, class, mix design. So in terms of mix design kasi, class, ito na yung parang ikaw ang gagawa ng sarili mong mix to attain certain properties of the concrete. Okay. So ang pinaka define na lang natin pala. Okay. So this is the process of selecting suitable Ingredients. Ingredients of concrete, by which of concrete. Okay. With certain with certain properties. Okay. So again, class, no? We have to consider, so parang pinaka-consideration natin class in selecting the ingredients is cost. Tapos yung minimum required properties. Required properties of the concrete. Okay? So, ituloy natin class, no? Ay, dapat pala hindi ko linak yan. Okay? So, tuloy natin class. So, meron tayong certain special types of concrete. Okay? Namely class, meron tayong high-strength concrete, high-performance concrete. Tapos meron tayong tinatawag class ng self-compacting concrete. Okay? So, may video tayo dito class for the, para mas detailed yung explanation niya. Okay? Ito. So, technically class, meron tayong different types ng concrete kasi, no? Yan. Meron tayong different special types kasi may special sila kasi yun ka. Parang meron silang specific property. So dito na galing yun class. So yung mixed design natin, ito. Diba? Kasi class ikaw yung gagawa nung pimili na ingredients. So yung mga concrete produced class from your this mixed design class, no? Ito na yun. Ito yung mga yun. Okay? So panoorin natin class. Wait. Check ko lang yung playback para mabilis. Okay.
Plain cement concrete. Concrete is a composite material composed of binder that is cement or lime, fine aggregates that is sand, and
so ito pala yung una class, meron tayong tinatawag na plain cement concrete or yung PCC. Okay? So again class, baka sabihin nyo redundant na cement concrete. Again class, ginagamit natin cement concrete para ma-distinguish sila from yung lime concrete tsaka yung gypsum concrete.
Concrete is a composite material composed of binder that is cement or lime, fine aggregates that is sand, and coarse aggregates mixed with water which hardens with time. The fine aggregates fill the voids of coarse aggregates and the voids of the fine aggregates are filled with the binder. This binder reacts with water and binds the aggregate and forms a complex matrix. This composite form is called the concrete. To know about how to manufacture the concrete, watch the videos in this playlist. Link is available in the description. There are many types of concrete available. We are going to see this in our upcoming videos. First, let's start with the plain cement concrete. This is the simplest form of concrete which are made only by mixing basic ingredients. These types of concrete are mainly used in the construction of the pavements and the buildings, especially in areas where there is requirement for low tensile strength. It is also used as bed concrete below the footings and walls and sill concrete below the window and ventilator. We will see the other types of concrete one by one in upcoming videos.
So yan, okay. So kung isa-scan natin class yung types ng cement concrete natin, no? So ito lahat actually yan. Pero ang kinuha ko lang class, so yan. So yung plainness of them all class, no? Ito. Plain cement concrete, meaning walang dagdag dyan class. Yan na talaga yun. Yan yung cement, aggregates, tapos water lang. Okay? Tapos, ito. So, si reinforced cement concrete class, ang nadagdag dito class, meron na siyang bakal. Okay? Kumbaga kasi yun nga, di ba class, concrete is strong in compression, pero steel is strong in tension. Supposedly class, for them to help each other, nabuo yung reinforced concrete. So, reinforced concrete class is concrete with reinforcing bars. Okay? Tapos meron din tayong tinatawag na prestressed concrete. Okay? So, technically, ang prestressed concrete class, meron niyang tension bars sa loob. Kumbaga, in-stress na yung concrete class para mas lumakas yung binding nila. Tapos, mas lumakas rin siya class in terms of yung tension. Okay? Tapos meron din tayong precast. So, di ba, ito yung isang type na discuss natin sa classification, meaning, it is casted in the factory class tapos brought to the site for bonding. Okay? So, meron din tayong lightweight concrete class. Again, ito yung mga ginagamit natin class kung medyo gusto natin na mas magaan class yung upper floors natin. Okay? Tapos, high density, hindi ko na ito kinuha. Ito, si ready mix concrete class. So again, itong ready mix concrete class, matic na siya. Pagka madating sa site class, buhos nyo na. Okay? So meron tayo ng high strength concrete class. So ito na yun, nandito sa module natin. So supposedly class, it is the concrete with the compressive strength of 40 megapascals and above. Okay? Tapos meron din tayo class ng high performance concrete. So ito na yun class. So technically, high performance class, ano ba dito? Ito yung parang 3 considerations niya. The structure, ayan, so na yun. Ito, high strength. Yeah. I-discuss na lang dyan class, pero technically, in a way, ang high performance class is also a high strength concrete. Tapos, other properties of the concrete are also, improved. Okay. Tapos yung self-consolidated concrete class, ito naman yung self-compacting concrete. Kumbaga, hindi mo siya kailangang i-compact class. Tapos yun, pag siya, parang sarili niyang i-compact yung sarili niya. So, kumbaga, pagkabuhos mong ganyan class, ang end product natin, yung surface niya, flat na. Okay? Kumbaga, ile-level niya yung sarili niya. Tapos shotcrete class. So, ipapakita rin natin yung shotcrete class. Ano ba yung tsura ng shotcrete? Okay. Tapos kinuha rin yung previous concrete. So, previous concrete class, minsan kasi ginagamit na yan para diretso na siya sa kanal kahit hindi na siya mag-flow dun sa gutters. Okay. Tapos yung asphalt concrete class. Yan yung mga kinuha ko. Okay. Then again, class, marami pa yan. Okay. Pero yung discuss ko lang, yun lang yung dito sa video natin. Okay. So, panoorin na natin, class.
Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views and finally don't forget to subscribe our channel. Reinforced cement concrete. The hardened concrete is generally high in compressive strength, but its tensile strength is very low, which is generally approximately 1/10 of its compressive strength. We can say as, concrete is strong in compression and weak in tension. To strengthen the concrete section in tension, reinforcement steel is embedded into the concrete. This composite section is called reinforced cement concrete. The reinforcing steel also imparts the ductility to the concrete, which is primarily brittle. The reinforcements are embedded into the tension zone of the section to counteract the tension force acting in the section. Most of the modern-day buildings are constructed using this type of concrete. In case of compression members, reinforcing steel also acts as a supplement in bearing compressive forces. Recent times, polymers are also widely used for making reinforced concrete. We have already made a video on this, link available in the description. The usage of reinforcements such as size and numbers of reinforcement steel should be designed based on the various factors, and it also should be confined to a specific code of practice. Improper size and number of reinforcements may result in failure of the structures. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views and finally don't forget to subscribe our channel.
Sakit sa tenga.
Pre-
So, andito na tayo sa prestressed concrete, no? So, yan yung sinasabi ko. Pag pre-stressed concrete yan, parang meron silang cable na ilalagay. Tapos hihilain yan, class. Isi-stress siya, kumbaga. Okay. Tapos yun, habang naka-stress na to, ilalagay yung concrete, tapos titigas siya. Pag tumigas na, saka i-let go, class yung stress. Okay?
Stressed concrete. In case of big concrete construction projects like bridges, steel reinforcement bars alone won't be sufficient to provide the necessary tensile strength. In this case, pre-stressed concrete is being used. In pre-stressing, the rods or tendons are stretched along the axis and cement is poured. Later, when the tendons are released, the compression is generated at the bottom, which tries to counterbalance the compression due to loading at the top part of the beam. The principle behind pre-stressed concrete is that compressive stresses induced by the high-strength steel tendons in a concrete member before loads are applied. This will balance the stresses imposed in the member during the service. Pre-stressed concrete can be used for the construction of roofs, floors, walls, and bridges with longer unsupported spans. Pre-stressing is generally done by two methods, pre-tensioned concrete and post-tensioned concrete.
Ayan pala, kasi may difference yun. Okay. So, pag pre-class yun, hinihila na siya before ilagay yung concrete. Post-tension naman, class, saka lang hihilain, class, if nalagay na yung concrete. Tignan na natin.
Pre-tensioned concrete. Pre-tensioned concrete is those in which the tendons are tensioned before pouring of concrete. The tendons are initially tensioned and anchored at both ends, and then concrete is poured over it and cured. When the concrete attains desired strength, the tendons are released and projections are cut out. The pre-stress imparts into beam through bond action. Post-tensioned concrete. In post-tensioned concrete, the tendons are tensions after the concrete is poured. Initially, the concrete is cast around the sheathing. The ducts are formed in concrete in which tendons are placed. After the concrete is hardened, the tendons are tensioned by hydraulic jacks and anchored. In case of bonded type tendons, the duct is grouted with sufficient slurry. In the unbounded type of tendons, grouting is not necessary. We will learn about this later. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel.
Mas masyado.
Precast concrete. In certain places where there is limited availability of space in the construction site, it is difficult for storing the material and preparing the concrete. In such cases, concrete is cast at factories and brought to the construction site and assembled together. In general, precast concrete is a product produced by casting
So, ito na pala, class, yung precast concrete, no?
concrete in a reusable mold or form, which is then cured in a controlled environment, and then transported to the construction site and assembled in the required place. These precast concrete members are cast either as plain concrete or reinforced concrete or pre-stressed concrete. This is far faster, safer and more affordable way of construction than standard concrete, which is poured directly at the construction site. Precast concrete allows efficient, economical construction in all weather conditions. Precast concrete is being used in wide range of fields like building units, landscaping products, sanitary and stormwater products, paving units, traffic barriers, and so on. Most of the bridge components are prepared using the precast technique. The other common examples of precast concrete are concrete blocks, the steps of the staircase, precast walls and poles, concrete lintels, railway sleepers, many other elements. The main disadvantage is it requires high-skilled laborers for installation of precast products. Proper connections must be made between each precast product, or else load distribution may not be uniform and sections may even fail. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel.
Lakas. So, ito naman, class, yung sa lightweight concrete. Parang may ambag ako sa video, class. Babasahin ko na lang kung ano yung...
Lightweight concrete. Lightweight concrete is commonly used in the construction industry where it is important to reduce the density of the concrete. Ordinary concrete is quite heavy and its density is about 2,300 kg per meter cube, whereas the lightweight concrete the density is less than 1,840 kg per meter cube. Lightweight concrete is made by replacing some or all the normal weight aggregate with lightweight aggregate. Often the coarse fraction is replaced with lightweight aggregate and the fines are normal weight sand. This lightweight concrete not only results in reducing dead weights on structure but also has a better insulation against heat and sound. However, the strength of concrete is reduced. The most common uses for lightweight concrete are with floor, roof and bridge decks. Others include pavement systems, masonry blocks and offshore oil structures. Lightweight concretes can either be lightweight aggregate concrete, formed concrete or autoclaved aerated concrete. Lightweight aggregate concrete. This type of concrete can be produced by using a porous lightweight aggregate of low apparent specific gravity. The examples of lightweight aggregates are the pumice, perlites, and scoria. Formed concrete. This type of concrete is formed by introducing large voids within the concrete. Formed concrete is a highly workable, low-density material which can incorporate up to 50% entrained air. Lightweight structural concrete. Lightweight concretes can also be used for structural applications, with strengths equivalent to normal weight concrete. These are generally made with expanded shale, clay, slates, slag, and fly ash. The minimum compressive strength would be 17.24 Newton per millimeters square. We will discuss more on this later. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views and finally don't forget to subscribe our channel. Ready mix.
Yeah. So, ang next type of concrete class is yun nga. Discuss natin kanina. Ready-mix concrete. Okay?
Concrete. Ready-mix concrete, that is RMC, is a type of concrete which is manufactured in factories, which is called as batching plant based on the engineered mixed design. The mixed concrete is brought to the construction site by truck mixers or transit mixer. The transit mixer is of two types. One type is the concrete made dry at the batching plant, loaded into agitated truck mixers and water added during transportation. In the other type, mixed wet concrete is made at the batching plant, discharged into the agitated truck mixers and transported to the site. The drum in concrete is made to rotate till the concrete is placed in order to keep concrete in a plastic state. We will see about the manufacturing process involved in ready-mix concrete later. It allows speedy construction through programmed delivery at site, mechanized operation with the acceptable economy. Usage of RMC reduces the labor cost and site supervising cost. The consistency in the quality of concrete is maintained through accurate and computerized control of cement, aggregates and water as per mixed designs. Usage of RMC also reduces the wastage of raw materials during storage. The main disadvantages of RMC are it requires special formwork arrangements since the movement of concrete through pumps can cause vibrations. And, if the transit mixer is in not proper condition, there is a chance in the loss of quality of concrete. Recent times for large construction works, a small batching plant is set near the construction site where transit mixers may not require. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views and finally don't forget to subscribe our channel. High strength concrete.
So, dito na tayo class sa high strength concrete. Okay? So, continuing the video.
High strength concrete is a type of concrete which has compressive strength of 60 MPa or greater. The compressive strength is generally measured on 150 into 300 mm or 100 into 200 mm test cylinders, generally at specific age depending upon the application. Some of the basic concepts in preparing high strength concrete are: aggregates used must be strong and durable. Generally, small size aggregates are used for making high strength concrete. High strength concrete generally uses low water cement ratio which ranges from 0.23 to 0.35. Thus, superplasticizers are added to obtain the desired workability. The total cement content for this type of concrete should not be more than 650 kilograms per meter cube, as high cement content results in cracking due to hydration. Sometimes to obtain the desired strength, cement is mixed with supplementary materials like fly ash, ground granulated blast furnace, natural pozzolanic materials etc. are added. In addition, the components of the design mix like mix proportioning, the shape of aggregates, supplementary cementitious materials, and superplasticizers should be given special care while designing. The most common applications are to put the concrete into service at a much earlier age, for example, opening the pavement at 3 days. To build high-rise buildings by reducing column sizes and increasing available space. To build the superstructures of long-span bridges and to enhance the durability of bridge decks. To satisfy the specific needs of special applications such as durability, modulus of elasticity, and flexural strength. Some areas of use are dams, grandstand roofs, marine foundations, parking garages, and heavy-duty industrial floors. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views and finally don't forget to subscribe our channel. High performance.
So yun, ang next type class ng ating concrete is yung high performance concrete. So yun yung second dito sa module class, no? So previously pala yun yung high strength, yun yung nandito sa una. Okay?
Performance concrete. High performance concrete is a type of concrete which possesses high workability, high strength, high modulus of elasticity, high density, high dimensional stability, low permeability and resistance to chemical attack. High performance concrete is also a high strength concrete, but it has a few more attributes as mentioned already. High performance concrete is made with materials similar to conventional cement concrete, but the special care is taken for selection of materials and mixed design. In addition, the admixtures are added to the concrete based on the purpose of the concrete to be used. We have already made videos on admixtures, links are available in description. The manufacture of concrete is done in such a way that the resulting concrete will give excellent performance for the intended purpose. The primary application for this type of concrete is to construct a structure which requires long service lives such as oil drilling platform, long span bridges and parking structures. High performance concrete still requires good construction practice and good curing to deliver high performance. The initial cost of this type of concrete is higher than the normal concrete. However, maintenance cost is reduced comparatively as high performance concrete suffers less damage. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views and finally don't forget to subscribe our channel.
So next up class, yan nga. Ito na yung third dun sa module natin, yung consolidated or yung self-compacting concrete. Okay?
Consolidated concrete. Self-consolidated concrete is also known as self-compacting concrete. It is a highly flowable, non-segregating concrete that spread and fill in the formwork without any mechanical vibration. The importance of self-compacting concrete is that maintains all concrete's durability and characteristics, meeting expected performance requirements. The spread of self-compacting concrete in a floor table test ranges from 455 mm to 810 mm. The two main important properties of self-compacting concrete are flowability and stability. The flowability is attained by using high-range water-reducing admixtures, not by adding extra water. The stability towards segregation of the plastic concrete is attained by increasing the fine aggregate or by using admixtures which modifies the viscosity of the mixture. Self-compacting concrete with a similar water-cement ratio will usually have a slightly higher strength compared with traditional vibrated concrete. This is due to the lack of vibration providing an improved interface between the aggregate and hardened paste. Self-compacting concrete is mainly used in areas of congested reinforcement. It is also used in bridges and precast sections. This type of concrete can be easily pumped to the specified point. This type of concrete is ideal to be used in drill shaft columns, earth-retaining structures, and areas with high concentration of rebar and manufacture of concrete pipes. Some of the special benefits of this type of concretes are: minimizes voids on highly reinforced areas, reduces skilled labor, easily flows into complex forms, excellent bond to the reinforcing steel, and so on. Catch you later with another interesting topic. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel. Shotcrete.
So, yun class. So, ang next step naman is yung shotcrete or yung sprayed concrete natin. Okay? So, ito exciting class.
Shotcrete or gunite or sprayed concrete is a concrete conveyed through a hose and pneumatically projected at high velocity onto a surface. For structural uses, shotcrete is usually applied over a framework of reinforcing bars and steel mesh. It achieves compaction into every part of the mold or formwork simply by means of its own weight without any segregation of the coarse aggregate. This type of concrete has no special properties as compared to normal concrete placed under similar conditions. They are generally applied in two ways, namely the dry process and the wet process. In the dry process, a predetermined dry mix of cement and aggregate is propelled through a spraying nozzle, where a finely atomized spray of water is added to the stream of materials before being sprayed. In the wet process, the bashed wet concrete is pumped through a hose or pipe to a discharge nozzle where high-pressure air propels the concrete into the required position. There are many applications and uses for sprayed concrete. Some common places where shotcrete is used are thin and lightly reinforced sections like curtain walls, etc., shell or folded roofs, the lining of tunnels, canals, etc., stabilizing rock slopes, encasing steel, repair of the old building and disintegrated leaking lining, etc. The main disadvantages of shotcrete are it has high cost and the shotcrete lining is less durable than the ordinary concrete lining of the same thickness. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel.
So, yan class. So, ito na yung second to the last type of concrete natin class, yung pervious concrete.
Pervious concrete. Pervious concrete is a special type of concrete which has high porosity to allow water to pass through it, thereby reducing the runoff from a site and recharging groundwater levels. Pervious concrete is also called porous concrete, permeable concrete, and no-fines concrete. The high porosity is attained by a highly interconnected void content. Pervious concrete consists of cement, coarse aggregate, and water with little to no fine aggregates. The high porosity reduces strength compared to conventional concrete mixtures. However, the strength can be increased by adding the required fine aggregates. The mixture generally prefers a water-cement ratio of 0.28 to 0.40 with a void content of 15 to 25%. The average flow rates for water through pervious concrete are typically around 0.34 centimeters per second. Pervious concrete is traditionally used in parking areas, areas with light traffic, pedestrian walkways, and greenhouse construction. It is an important technique for sustainable construction. This method is also widely used for the construction of pavements for preserving stormwater runoff. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel.
So, ito na yung last type of concrete na i-discuss natin class. I-discuss tong video. So, yung asphalt concrete. Okay?
Asphalt concrete. Asphalt concrete is a type of concrete in which the cement is replaced by asphalt, a dark, sticky substance derived from crude oil. Asphalt concrete is commonly used in the construction of surface roads, parking lots, airport roads, as well as the core of embankment dams. This concrete is manufactured in different ways. Most commonly used method is pouring the hot asphalt over a bed of aggregates and then pressed into it with a steam roller. Once the asphalt cools to the surrounding air temperature, it becomes strong enough to withstand automobile traffic. Even though asphalt is extremely hard and durable, it offers enough flexibility to accommodate imperfections in underlying surfaces. In recent times, the asphalt concrete paving machines are being adopted, which delivers the mixed asphalt concrete. Advantages of asphalt concrete pavements are: it is economical compared to cement concrete. Moreover, it takes less time to build an asphalt road than a cement concrete road. Asphalt is a recyclable material. It can be used again and again by melting it. Repairing of the asphalt road is easily possible. Damaged areas are filled with fresh asphalt, and a steamroller goes over the entire surface to yield smooth, even pavement. Thank you for watching. Stay tuned. The best is yet.
So yun class, so that's it for the types concrete natin. So again guys, i-summarize ulit natin. Okay. So yeah, 4.10. Tawagin na lang nating types of concrete. Okay. So, i-list ko lang, no, class, kung ano yung mga pinag-discuss doon sa video. So, again, class, meron tayong tinatawag class na pre. Ialisin ko na class yung mga na sama kanina, no? So, yung mga ready mix, yung mga lightweight, yung gano'n. So, meron tayong prestressed concrete. Okay. Tapos, meron tayong high strength concrete. So, ito hindi pa kasi discuss ko sinabi ko na, no? High strength concrete. Okay. Tapos, again, meron tayong high performance. High performance concrete. Okay. Tapos, ay yung self-consolidating. Gusto ko yung self-compacting tayo. Compacting concrete. Okay. Tapos, shotcrete. Tapos nga natin. Ay. Sige, sa gilid na lang kadi. So, after shotcrete class, number 6 dito na lang, no? So, meron tayo ng pervious concrete. Okay. Tapos last class na hindi binanggit is yung asphalt concrete. Yan. Okay. So lahat class yung kanina, yung lightweight concrete, yung ready-mix concrete, yung precast concrete. So hindi ko na sinama dito kasi discuss naman na kanina. Okay. So that's it class for part 5 natin to. Part 5 of module 4. Okay. So kung titignan natin pala class. So after nun, we continue class, no? Part 6 class will discuss the testing of concrete. Okay. So again, class, thank you for staying. See you at the next video. Bye.